Hey, I don't really see anyone yet, so I'll wait a few minutes before I make a start. Hey guys, okay, I don't really have a huge workshop or anything for this meeting, so it was supposed to be a jamming session with debugging, so I guess it's mostly up to you guys and the questions you have and anything you want to know, but just to make an intro. Uh, yeah, I'm here to talk about ideas and the things you want to build. If you need any help and everything, like anything you want, basically, and let's just talk about it. Second thing is something that we haven't said yet, I think, is and there will be bonus points for like combining tracks. So we really encourage you guys to make something fun with a few bounties, a few projects. So my personal preference, using Herodotus with art and Dojo or Pragma sounds very interesting to me. I would love to see a project doing something like this. Uh, and just another one more thing is there is a new tool available for you guys. So it's the Explorer. I will post a link on the Discord chat as well, but you have it in the presentation. We'll come back to that. You can basically right now come in here, register, just log in with GitHub, and you can browse and see all your queries. And then you will be able to like see all the statuses, all the subqueries you made, and in the subqueries you can see the process real time. So it's just a tool for you guys to understand things better and see everything and like what is happening live in our system. So yeah, that's a nice new tool. From the old tools that I'm not sure you know about, there is also the Herodotus MMR visualizer. So you can basically have a look how MMRs work, how they are built, how the proofs work, and everything else. So yeah, I really recommend guys to just check it out if you're interested in this kind of things. But yeah, coming back to this, uh, I'll be here all this time for the whole duration of this workshop, and I really encourage you guys to like talk with me if you have anything to talk about. So I'll just leave it at that and wait for you guys to activate.
Hi, good day.
Hey,
Uh, can anyone hear me?
yeah, I can hear
All right, good day, Prince. uh, joining from Nigeria. So
Nice.
I don't know. I would say I'm pretty late to the hackathon. It's not been long when I started learning about Cairo and Starknet. So uh, um, I just started reading about Herodotus yesterday. So I'm still trying to figure out what Herodotus does, and I started going through the documentation yesterday because I'm planning to build my hackathon project on using Herodotus. So I started going through docs yesterday, and I think I'm catching up on what it does. So I don't know if you could, if you can help me. I don't know, just like a breakdown of like an overview of Herodotus and how it can be applicable to building uh, projects on Cairo. As I said, I just
Sure.
started going through it yesterday, and maybe you could give an head start. Maybe your breakdown could give me an head start on what I can build on Herodotus for the hackathon. Thank you.
Sure. Sure. Okay. Yeah, I think that's a nice thing to like talk about. So okay, Herodotus itself. Let me just another the website. So we do storage proofs. So basically storage proofs themselves are just a concept. So you prove some storage, and for this hackathon, you're probably interested in proving stuff from Ethereum on Starknet. So Ethereum is EVM, Ethereum Virtual Machine, and then you have a storage layout on Ethereum, a specific storage layout. Like everything is written in depth in our docs. So if you want to know those like technicalities and low level stuff and like more theoretical knowledge, then you can have a read and see anything you want. So this is would be the storage proofs thing on our documentation. But let's like focus on like the practicalities and doing stuff. So we do storage proofs simplified for you. So you don't have to worry about the whole flow. You don't have to like understand fully the whole concept. You don't have to like code the whole infrastructure for yourself. You just use Herodotus, and this way you will get storage proofs from one chain to another, or historical storage proofs within one chain. But yeah, let's focus on Ethereum to Starknet. So you can basically now use any data, any information from the L1, which is Ethereum, and in this case, I don't know, Gurley or Sepolia or whatever you choose your testnet to be. Oh, I think it has to be Gurley for the hackathon. So yeah, Starknet Gurley and Ethereum Gurley. Okay. So you basically can prove any storage from Gurley and make it available on Starknet. So the flow itself, as you want to use it, would be to go on the Storage Proof API, see the interactive docs, and then here you have one query that you really want to use, which is the submit batch query. Don't get discouraged by the batch query. It's just like you can ask many things in one query instead of doing a lot of queries. Okay, so basically you provide a destination chain ID. In this case, it wouldn't be Sepolia, it would be Gurley for the hackathon. So Starknet Gurley, you have all the available fields in here. So you would choose Starknet Gurley, and the origin would be Gurley, so number 5. And yeah, the fee is 0 because like you don't have to pay for testnets. And then you provide the origin chain in here. So you've provided Starknet Gurley here. You provide 5, which is Gurley here. And then you basically ask for something, ask for a proof. And there are multiple proofs that we like support. Uh, but you're probably like mostly interested in proving a header. That's when you're doing mostly like low level stuff. So, or yeah, it very much depends on your idea. But yeah, the header. So you can ask for a header to be proven and available on the destination chain. So in this case, you would move the block number, like, what is it? Like 5 million something to Starknet. And this way you can access, for example, historical data or like or the newest blog or anything. You can just move it to Starknet and access fields from the header on the Starknet. And then you can also access blogs by a block number or by their timestamp. So this will get the closest block number to this timestamp and prove it for you. But other fields that are probably more interesting is like proving accounts as if address as in addresses and also smart contracts. So for example, in here we prove the ENS name, the contract assigned to the ENS name of Vitalik Eve, and we prove the balance, the nonce, and the storage root in given, in this case, timestamp. Another example, we prove some other contract and we prove balance. Another example, we prove both the header and the contract, and in here we prove slots. So this was pretty straightforward. So you just provide an account and you provide the properties from the account you want to use. This is like pretty straightforward. And if you want to build something around nonces, balances, or anything else, that's quite easy. But then the fun starts when you want to prove storage slots. So yeah, this one is a little bit deeper. And I don't think I'll be able to like fully explain it on this call, but definitely I can just send you some resources and you can just go through it, have a look, but I'll touch on it shortly. So yeah, to recap, you can prove the header, you can prove accounts and properties of the accounts, as well as storage slots. So this is basically the query. Optional thing for the query is a webhook, but this is more like designing your system. So you basically first send a request to Herodotus with asking what you want to prove, and then you wait for Herodotus to prove it, and then you access it. So you have to somehow like know if it's already done or if it's pending. So this is not a like immediate, very, very short task. It won't take 10 seconds. It's more like from 1 minute to 15 minutes, depending on what you request. That's why we give you the option to provide a webhook URL. So we can just ping you back when you finish. But there is also another way, which is a batch query status. So once you submit the batch query, you get an ID and you just paste the ID and you can see the status of your query. But for this purpose, you can also use the new Explorer that I've shown you right now. So yeah, I'll leave links to everything. Okay, but to continue, so this is the first part. So you send a request to Herodotus that you want to prove something. This thing is proven for you, so like you don't have to care about anything here apart from when it's done. And when it's done, then you have to use it somehow. So there are generally two ways of using the thing that you've proven. So it won't be available in the webhook, it won't be available from the API itself because the proven things live on chain. So we don't like provide a quick way to access it yet. And like we don't really want to. So this is an on-chain thing. So this data that you've requested off-chain through the Web2 API, you get available on-chain in this case on Starknet. So now a question like how to use it and what to do with it. So I pasted this on Discord. So I'll just grab the link from here so you know what I get it from. Okay, so here is like a long list of links. And basically, I recommend those two links here. So one of them, one sec. Okay, I'll just open them first and then I'll go through them. Okay, so one of them is showcasing using the proven data off-chain. So in a Web2 backend or whatever else. And the other one is showing how to use the data on-chain. So in Cairo contract in this case. So for this one, because it's easier, basically, this is a whole tutorial so you can go through it. And this is actually a very nice resource to have a look at how to get slots, because storage slots are, as I mentioned, a bit more complicated. So you have to actually know what you're getting and not just provide, I don't know, that you want a nonce, because that's very simple. Storage slots are a bit more complicated. But yeah, after you've proven something, there's the step 3 in this tutorial. You want to access the data. So the data lives on chain, so you have to read it from chain. What you do is you grab Herodotus fax registry contract address. This is available in the docs. You can have a look in the docs on the contract addresses. Depending on the chain, you're interested in Starknet Girly. So you have a fax registry contract here. You grab it, you put it in code, and then you basically want to an RPC provider, and you want to get the contract address here, and then you basically ask the contract for whatever you've proven. So for example, in here, we want storage slots because like we've in this tutorial that I'm like showing the code of, we proved 2 storage slots. So basically what we do is we get the contract. So this is this contract that we grabbed from the documentation, the fax registry, and we just get the slot value that we want. So we provide the things that we've also provided to the API. So in the API, you had to provide the address of the account, in this case, the app contract address, the block number, and the actual slot that you want proven. So now you basically grab those 3 things again, and you read the contract directly, and you get the slot value. That's it. Or the same thing is applicable for anything else. So let me show you how it looks. Contract addresses, fax registry. Let's go and start scan. Sorry, testnet. Yep, nice. And now you can go into read write contract. And here in the read section, you can see all the things that you can read. So if you made a request, like we talked about in here, if you made a request about, for example, an account and you asked for a nonce, let's say, then you basically have to interact with the fax registry contract to get an account field. You provide the account, so 0x something, something, something. Then you provide the block in which you've proven something, so like 10, and then you provide the field that you've proven. So in this case, you want to provide nonce, right? So that's basically how you access it. But the problem with accessing it quickly like this, at least for the account fields, is that start scan is not really very good at handling like enums from Cairo and returning the correct values like formatted correctly. That's why I really recommend to just to just have a look at this code and just do it in code by yourself and like print the value if you want to, or just do whatever you want with it in your system, but it's way more reliable this way. Okay, so this is the first way, which is accessing stuff off-chain. So you just do whatever you want to do to read data from an on-chain contract off-chain. So you can use it in code, you can do it in code, or you can just do it in some explorer that works. But yeah, apart from this, there's this second tutorial for that like charity token or whatever. And in here, there are actually contracts, and you can see how to interact with the fax registry contract on chain in Cairo. So basically, you create an interface in Cairo, and you grab the function that you want to interface with. So all of this is available if you go to like Herodotus and you go to Starknet contracts, Herodotus and Starknet, and the fax registry contract. And basically, it has a huge interface. So you just want to grab the thing you want. So if you want to get the header, you grab this function. If you want to get an account field, you grab this function. If you want to get a slot, you grab this function, and so on. So in here, we just have this minimal interface of the fax registry contract of the things that we want. And in here, you will be also able to see how to use this. So you just have to grab the address again. So this is still the same address that we had a look at before. And then you basically interact with the fax registry. So you get the dispatcher. Yeah, this is just Cairo stuff. So if you don't know Cairo, it won't probably tell you much. But if you do know Cairo or you just want to code something, then you can just grab it, copy paste it, and you're good to go. So yeah, you provide the address that we grabbed from the docs, and then you use any function you want. So in this case, we are interested in a slot value. So again, account, log, slot, we have everything. So yeah, just a quick recap. You request something from Herodotus, wait for it to be done so you can see it in a webhook or on like the Explorer or whatever, and then you access it. And the data you've proven lives on chain, so you have to access it from chain. So if you want it off chain, you have to get it from chain somehow. And if you want it on chain, you have to write a contract that will interact with the on chain data. Okay. Yeah, that was a bit long, but yeah, it's not that easy to explain. So I'll link all the things, and I really think the easiest way to have a look at this is to just follow this one. Just go step by step. You'll learn how to get storage slots as well, and it should tell you everything. And if you need the contracts on chain, then follow this one. So it's just either one of those. Okay,
All right. Thanks a lot for that. I think that helped a lot. So
cool.
I don't know, like the idea of validity proofs. I'm still trying to wrap my head around it because I've always been a Solidity dev, and joining the Cairo Starknet ecosystem, and it's kind of new to me, though I've not done ZK proofs before. So I don't know if the validity proofs you mentioned earlier on is like in any way related to ZK proofs, or it's uh, something entirely different on its own. Uh, I don't know.
Okay.
If you,
Yeah, so I'm mostly talking about storage proofs. Yeah, storage proofs are not ZK by nature. So if you have a look at the docs, maybe I'll find a quick graph that I can just talk about briefly. One sec. Okay, that will probably okay, yeah. So a storage proof is actually like very easy concept. So you have some roots of some like tree, which is a storage on Ethereum. There is a block. So in the block, you, for example, have the state root, which is like the root of the state of the block. And the root of the state of the block represents a commitment of the whole state. So basically, if you have like the root, you can validate something from within the state. So in this case, for example, like if you want to prove the nonce, you have to have all the remaining values, like the values that you need for a proof. And you basically plug in the nodes that you want to prove, and all the other values are given. And when you like hash everything up the tree again, then you should end up at the same root. If the roots match in the end, it means a proof is valid. This is kind of like a holistic, not really detailed view of what storage proofs are. So basically, they prove that some storage is valid. It's nothing complicated. And about ZK in this, there isn't ZK directly, but indirectly, we do use ZK and we do use Starks and stuff like this. So basically, if you want to prove a lot of proofs, and if you want to prove a lot of blocks, and if you want to prove like historical data, so if, for example, want to prove a block that is 18 million blocks away, you want to prove the genesis on Ethereum, then you have to do a lot of proving. And basically doing all of this so that it's safe and trustless would mean doing it on chain. But then on chain, it would be like absolutely incredibly expensive. So this is where ZK comes in. You can basically do all the computation off chain and then prove the huge computation on chain. So this is basically what we do sometimes. We don't always do it. It depends on the request. So if you want something fast and quick, then we calculate it for you. But if you want to access, for example, like something very, very old, very, very far away, or very, very big, then we would do it off chain and prove the computation on chain. So this is where the ZK part comes in. But storage proofs like directly are not really related to ZK. Hope it answers the question.
Yeah, thanks a lot. It answers the question. So thank you. And lastly, I don't know if there is like, I don't know, a forum or a kind of medium where we can meet and talk to other developers building using Herodotus, because I joined the Discord server and it was kind of quiet there. I was hoping I would see developers building Starknet Hackathon. I was hoping I would see them there, but it was quiet. So I don't know where to meet other developers building on Herodotus for the Starknet Hackathon.
Okay, that's an interesting question. Maybe we'll do it this way. That after the call, I'll try to gather all the interesting links and just post them on the Herodotus Bounty channel. I'll just send them there, and there will be like invite links to some Telegram groups and anything I come up with. I'll also ask like other developers. Maybe they have some interesting stuff. So yeah, we will make that post.
Oh, all right. Thank you.
Sure. Okay, so we're half an hour in the meeting, so we have like 15 minutes left. So yeah, I'll just wait around. If you guys have any questions, just drop them. And if you want to talk about anything, just yeah, just talk. I'll just be here muted and wait for anyone to activate again. Hey everyone, it's around 5 minutes to go, so last call for any more questions or just talking, because yeah, I'll wait around for like 2 minutes more, but unless anyone speaks up, then yeah, have a nice day. Okay, I think that's it then. So yeah, please do reach out on Discord or wherever, and let's just talk it through if you have any ideas or problems. And apart from that, have a nice day. See you and good luck on the hackathon. Bye.